Hey, everybody. It's great to be here today to share DOE's vision for our clean energy future and the role we expect geothermal to play in it. You know, President Biden's clean energy goals are going to put America on an irreversible path to achieve a 100% clean energy economy with net zero emissions not later than 2050. And at DOE, we recognize our essential role in executing President Biden's climate mission. For decades, DOE has been investing in innovative renewable energy and energy efficiency technologies, and now is the time to realize returns on those investments by getting energy solutions out into the marketplace at scale as quickly as possible. Our mission within EERE is to accelerate the research, development, and I'll underscore the demonstration and the deployment of technologies and solutions to equitably transition America to net zero greenhouse gas emissions economy-wide no later than 2050. This is going to create good paying jobs and ensure that the clean energy economy benefits all Americans, especially workers and communities that are impacted by the energy transition and those historically underserved by the energy system and overburdened by pollution. We've established 5 programmatic priorities to aid our transition to this clean energy economy. They are to decarbonize the electric grid, decarbonize transportation, decarbonize the industrial sector, reduce the carbon footprint of buildings, and decarbonize the agricultural sector. Our work within EERE will also be driven by 4 cross-cutting principles. First, we have to build this clean energy economy in a way that's going to benefit all Americans. We have to address the environmental and energy injustices that disproportionately affect communities of color, low-income communities, and indigenous communities. Environmental justice is highlighted in a number of new initiatives here at EERE, and we're deeply committed to executing the President's vision that 40% of our investments benefit disadvantaged communities. Second principle is that the success of the clean energy industries depends on a diverse STEM workforce. We will increase the awareness of clean energy job opportunities at minority-serving institutions. We will ensure that organizations who receive EERE funding are thinking through their own diversity and equity in their plans. Third, we're building out a more robust workforce training opportunity to build a pipeline for permanent, good-paying jobs for a clean energy workforce. Our workforce investments also must provide a pathway forward for communities and workers who have already risked their lives to reduce fossil fuels. And finally, we can't accomplish any of our targets without working really closely and learning from state and local governments, the entrepreneurial community, and allied disciplines that can help us to reach our climate goals. So there's a lot of work to be done, and advancing renewable energy technologies is critical to this transition to this clean energy economy. And as we all know, geothermal has tremendous potential. Sue Ham, the Office Director for Geothermal Technologies Office of the Department of Energy, puts it perfectly. She says it's America's next renewable powerhouse. The Biden administration is committed to helping the geothermal community reach its targets and establish geothermal as an important part of America's renewable energy mix. And I'm hoping that those of you listening today will join in that effort. As we look for ways to translate the oil and gas industry's expertise to advance the geothermal industry, there are clear opportunities for collaboration. One example that comes to mind is the American-made Geothermal Manufacturing Prize. For those of you who aren't familiar with the program, the Geothermal Manufacturing Prize is a $4.65 million competition designed to spur innovation and address manufacturing challenges fundamental to operating in harsh geothermal environments. The goal is to harness the rapid advances that additive manufacturing can provide in tool design, fabrication, and function, while incentivizing innovators to discover new advanced manufacturing solutions. And perhaps most importantly, it's designed so that people outside the traditional geothermal industry are empowered to participate. Prize is broken down into 4 progressive stages that allow competitors to earn cash prizes, to create a prototype, and to develop critical partnerships along the way. In October of 2020, the competition started off with 15 quarterfinalist teams, each selected for their proposed solutions to some of geothermal's toughest manufacturing challenges. In March of this year, 9 semifinalist teams moved on to the third contest, each winning $100,000 in cash prizes and $75,000 in technical support for demonstrating their design's promise in meeting engineering and operational requirements. Those 9 teams are now hard at work on creating prototypes of their technologies, which they'll showcase in a few months when they reach their next milestone. We created a short video series to showcase these talented teams, so you'll get to learn a little bit about their technologies in a few moments. These entrepreneurs are certainly well positioned to impact the geothermal and the additive manufacturing industries, but I see opportunities for the oil and gas industry here too. You probably know that one of the key components of harnessing geothermal energy involves decades-old practices like drilling to reach renewable heat sources. As the Biden administration looks to achieve aggressive climate goals by boosting our use of renewables, there's an increased demand for transitioning careers to the energy industry. We're seeing more job opportunities than ever before in the geothermal field, especially for those with expertise in areas like drilling and engineering and exploration. The oil and gas industry offers tremendous depth of experience in these and other related areas. That expertise is being put to use at DOE's Utah Forge site, where research teams are making great progress in testing and understanding enhanced geothermal systems, or EGS. EGS shows great potential for adding up to 60 gigawatts of new geothermal power to America's grid by 2050. Oil and gas experts are playing a crucial role and will continue to do so. There's also been a resurgence of innovation, something our country needs if we're going to be solving these pressing challenges to meet the 100% clean energy goals. Programs like the Geothermal Manufacturing Prize are opening doors for entrepreneurs to transition into this new opportunity with greater impact. It's so inspiring to see the mutually beneficial relationship developing between geothermal and the oil and gas groups. At the end of the day, the innovative ideas and solutions that result from the manufacturing prize can easily be implemented in both the geothermal and the oil and gas industries. And the work being done at the Forge site could result in a tremendous long-term benefit for our nation's green economy. This points to a broader topic that is of vital importance to the Biden-Harris administration, the American Jobs Plan. President Biden has challenged us. He's challenged all Americans to reimagine and rebuild a new economy. The American Jobs Plan is a once-in-a-generation investment that will create millions of good jobs, rebuild our nation's infrastructure, and reposition the United States as a global leader in progress and innovation. For those working in fossil fuels, this means creating new opportunities to transition to renewable energy, to build a more resilient energy grid and achieve carbon-free electricity by 2035. To do that, renewable energy has to take a lead role. Whether it's solar or wind or water or geothermal, all will factor prominently in the new green economy. We need all the resources we can get. The geothermal industry can not only draw on current oil and gas expertise in critical areas, as I mentioned before, but it can facilitate the growth of new jobs for those working with underground resources. This means mining jobs in addition to oil and gas. In fact, the DOE is currently supporting geothermal district heating and energy storage research at the University of West Virginia in Morgantown, the heart of coal country. Geothermal district heating has vast potential. DOE's GeoVision report shows that the number of district heating systems could increase in the US from 23 today to more than 17,000 by 2050. It's a huge target, but we think it's realistic. Coupled with the growth in geothermal power capacity, it means potentially tens of thousands of new jobs that can leverage fossil fuels workforce expertise. As another opportunity for partnership between geothermal and oil and gas communities is an ongoing prize called the Geothermal Lithium Extraction Prize, which is designed to find solutions that de-risk and increase market viability for direct lithium extraction from geothermal brines. This is a $4 million prize. It's fully accessible to those outside the traditional geothermal industry, particularly for those with experience in engineering, metallurgy, geochemistry, and similar career fields. This new prize tackles a problem that's lingered for years. How do we find a better, more cost-effective, and environmentally sound way to capture domestic lithium and other critical minerals? These valuable resources are critical to high-tech manufacturing and critical to a new clean energy economy. And they're here, right here. We don't need to rely on imports. We can secure the energy, the US energy supply by combining forces and finding solutions together. Just based on our audience today, I'm confident that many of you could participate in this competition. It's currently open and has recently expanded to include new competitors. We also recently extended the entry deadline for phase 1 to September 2. So I highly encourage all of you to learn more about the prize and consider competing or supporting a participating team on our website. So today we have talked about the need for collaboration between oil and gas and the geothermal industries at this critical moment in our country's energy narrative. We will start the next chapter, and as we do so, I challenge each of you to find ways to think creatively and to use an all-hands-on-deck approach to accelerate a clean energy economy for all. A few minutes ago, I mentioned a video series highlighting the Geothermal Manufacturing Prize competitors and their innovative technologies. So I'd like to share that now with you. If you see a product that piques your interest, maybe it's something you think you could contribute to or help test as a pilot partner, reach out to that team and make that connection. That's what these prizes are all about, cultivating connections that spur innovation. So thanks. And I hope you're enjoying getting a glimpse at some of these up and coming geothermal technologies.
I've been in the oil and gas for nearly 30 years now, and I've seen all elements of it from start to finish, from drilling all the way through to completions. I've seen all the unconventionals, all the other ideas that have come out that we've pursued. The new geothermal, this one, is the first one that I believe has really the potential to replace oil and gas for our grid. It's the first one. I don't see a downside, and I'm very excited about it.
So geothermal, renewable energy right now is more important than it ever has been. And the high cost of developing a geothermal well is a huge barrier to unlocking these natural resources. So the opportunities that we see come from lowering the cost of access to these resources.
I think there's a lot of opportunity, accessing these lower temperature wells, and then also improving kind of the overall reliability of line shaft pumps, different pumping technology used in geothermal wells.
We looked at 17 parts from existing geothermal tools, and we did a very detailed analysis of how you would manufacture them conventionally. And it turned out to be the case that if you just looked at making one-offs of these items, about half of them could be potentially made more economically using additive manufacturing.
So our technology is a metal expandable packer for annular isolation, and this will enable enhanced geothermal systems to be reliable and safe.
Airlift is simple. It's put a tube down the hole, blow air in the bottom of the well, and you produce fluids. It's just bloody simple, but it needs to be made more efficient.
So our innovation is pretty simple. It's basically a pneumatic hammer that goes down the hole. Instead of cutting the rock, we will break the rock. This technology will be good up to about 600 C. That is the biggest step in what we've done.
We at Downhole Emerging Technologies have invented a new isolation packer that is not only super high temp rated, in other words, it's all metal, but it also has a unique way of being deployed and retrieved so that it's easily deployed and easily retrieved.
This innovation can get us to where we are drilling geothermal wells at 25% their current cost. If this is the case, It is a game changer.
So one of the things that I'm interested in is exploring whether we can find other advanced manufacturing methods that can change how we think about making tools today.
Without this competition and the funding that it's provided, this technology probably wouldn't exist.